Hi guys. Okay, so today we're talking about logarithmic graphs and parent functions. So the logarithmic parent function is going to be f of x equals log of x. Remember, if you don't see a base, you assume it's base 10. So a log graph looks something like this, which is the inverse of an exponential function. We've already talked about exponential functions before. So basically, a logarithmic function is opposite of an exponential function. With that being said, let's just jump into number one really quick, the example one. Log base 2 of x. I can rewrite that as an exponential function. So I'm going to rewrite it. We see the base is 2. So in an exponential, we're going to say base of 2 to the power of x. Okay, so I'm going to build a table, and you guys already know how to build a table of an exponential function, especially super basic 2 to the power of x, right? There's no transformations or anything. We love to use -2, -1, 0, 1, and 2, and we've already done this example before. The y values are 0.25, 0.5, 1, 2, and 4. And how we get the y values, don't forget, it's just by plugging in each x value into the function. Okay, so what's an inverse? An inverse means a switch of x and y. So what is x now becomes y. So if I want to write a table for now log base 2 of x, I'm gonna just switch all the x and y values. So now instead of the y value being 0.25, for the log function, it's the x value. And then 0.5 for -1, 1 for 0, 2 for 1, 4 for 2. So see how we just switched the x and y values? This is what you're going to graph. This is your log function. So to get the log table, I need you to build an exponential table first, which you guys already know how to do that, and flip it. Flip the x and the y's. There's no transformations, so it's as simple as just plugging in, flipping your x and y's. So now I'm going to plot 0.25 down -2, 0.5 down -1, 1, 0, 2, 1, 4, 2. Okay, don't forget, it looks like an exponential, but now we're talking about opposites. Do you remember in an exponential function, they asked for the y-intercept? Well, now I'm asking you for the x-intercept, right? So the x-intercept is going to be my 1, 0. And I'm going to talk about the asymptote now. Remember, we had a horizontal asymptote for exponential functions. Let me draw that up here. Remember a horizontal asymptote for exponential functions? Now for logs, it's opposite. We have a vertical asymptote. If we don't see any transformations, we assume our asymptote is going to be x equals 0. So before your asymptote was y equals 0, now it's x equals 0, because now it's crossing the x-axis at 0. It's a vertical asymptote. So when I connect my points, I'm getting close to my vertical asymptote. I'm not going to touch it, right? So my graph is going to look something like that. Before we used to say the domain was all real numbers, but now since we're talking opposite, now the range is all real numbers, right? Top and bottom. The top goes to infinity, the bottom goes to -infinity, all real numbers. Your domain, though. So on the left side of your graph, we have an asymptote. On the right side, it goes to infinity, right? We're going to say our domain, which is x, and we're going to positive infinity, right? Do you guys see on the right side over here, going to positive infinity? So we say all numbers greater than 0, all the way to infinity. Your end behavior is also opposite. So as x, as we go to the right side, right? So let me circle it again. As we go to the right side, so going towards positive infinity, our y values go to positive infinity. But what about the left side? Well, the left side, we have an asymptote that's blocking. It's like a wall. This asymptote doesn't let our graph go past 0, right? That's where our asymptote's at. So I'm going to say, as x approaches 0, the asymptote, the f of x goes down to -infinity. Okay, so it's kind of opposite. So it's the same as our exponentials, but inverse, right? Opposite. Let me show you one with transformations. So number 2 is going to be the exact same thing, right? This one does not have transformations, but just to start you off, build your exponential table with your base of 1/3 to the power of x, right? And then flip. Okay, going on to transformations. Let me do one with a lot of transformations. Let's do number 5. Okay, so we're going to build our parent function exponential. So all I need is my base, which is 1/2 to the power of x. That's all I need for now. I see that I'm going to have these transformations right here. We don't worry about them right now. Let's just build a simple exponential function table with our base. Okay, so I'm building my table. I'm always using these numbers, -2, -1, 0, 1, and 2. And then the y values are going to be 4, 2, 1, -0.5, 0.25. Okay, let's flip it, right? This was just our exponential. Now we flip. So now let me write, oops, I'm so sorry. Now we write our log table. And all I'm going to do is flip the x and the y's. So 4, 2, 1, 0.5, 0.25, -2, -1, 0, 1, 2. Okay, so I just flipped the tables.
Sorry.
It's okay.
Can you print it?
Sure, but can you give me 1 second? I'm just recording a video. Yeah. Okay, now let's add our transformations. So the first transformation I see is a +9, right? Those are for my x values, but don't forget, this one is the only one that I need you to think opposite. So it's actually not going to be +9 to all the x values. It's going to be -9. So I'm going to subtract 9 to all my x values. So 4 - 9, 2 - 9, 1 - 9, -8.75. Okay, sorry. That does not look good. Let me write it underneath. So the last number is -8.75. All right, the next transformation I see is a +4. He's outside of the parentheses, so he affects the y values. And that one you don't have to think opposite. We're just going to add 4 now to all the y values. So this becomes 2, 3, 4, 5, 6. Okay, those are all the transformations that I have, right? So now I'm going to plot those points. So we have -5 up 2, -7 up 3, -8 up 4, -8.5 up 5, and -8.75 up 6. Okay, notice when we have transformations, our asymptote is going to change, right? So it's no longer at 0. Which one are you going to look at for the asymptote? Remember, before we used to look at the number on the outside, right? The k value. But since we're talking opposite now, we're going to look at the value inside the parentheses. So looking at number 6 right here, let me erase this really quick. For number 6, this is going to be your asymptote because he's in parentheses. For number 3, this is going to be your asymptote because he's in parentheses. But don't forget, you always have to think opposite. So my asymptote's not going to be at +9 for number 5. My asymptote's going to be at -9 because you have to think opposite, don't forget, on the h value. Okay, so there's my asymptote at -9. So again, I'm looking at the number inside the parentheses, just opposite. So I could already write my asymptote x equals -9. Okay, let's connect the points. Be careful not to touch. Try not to touch the asymptote. There it is. All right. Domain and range. Remember, range is now going to be my one with all real numbers. But my domain, we have everything. So we see going to +infinity, everything going to +infinity, but beginning at the asymptote. The asymptote's at -9. So we say x is greater than, all values greater than -9.